I'm gonna prove this is impossible with simple math.
Wow, that is so cool. Physics at work.
This is exactly how a hot air balloon works.
No, they're both faking it. In this frame, we can see the matchstick, which is 5 centimeters long, and based on that and the box and the candle flame, I triangulated the size of the cup. The volume of the cup, which is the truncated cone or frustum, is 1/3 times pi times height altogether multiplied by top radius squared plus bottom radius squared plus their multiplication. I calculated the volume to be 350 centimeters cubed and then found the same cup, which is stated to be 350 milliliters, confirming my numbers. Now let's compare the math for an air balloon and this cup scenario. For us to work, buoyant force upwards has to be greater than gravity downward. According to Archimedes, buoyant force is the air density outside minus the density inside times volume times gravity. To find air density, we can use the ideal gas law, PV equals nRT. We divide both sides by volume, and instead of n, we put the mass of air divided by its molar mass. Mass over volume is density, and since every term here is constant except for density and temperature, we can say they have an inverse relationship. This means the density outside of the cup or balloon divided by density inside is equal to temperature inside divided by temperature outside. Plug this into the buoyant force formula, and this has to be greater than mass times gravity for them to float. The outside air density is 1.2 kilograms per meters cubed, and the outside temperature is 20 Celsius or 68 Fahrenheit. I'll be super generous to the fakers and assume the inside temperature is the same for both the cup and the hot air balloon at 100 Celsius or 212 Fahrenheit. This means with the formula we derived, the inside density is 0.94 kilograms per meters cubed. And then we plug this into the Archimedes formula and calculate the buoyant force to be 0.9 millinewtons for the cup. For the balloon with a volume of 2800 meters cubed, the buoyant force is under 7200 newtons. Divide this force by gravity, and that's the maximum mass they can handle. For the balloon, it's 735 kilograms, but for the cup, it's only 0.09 grams, meaning it's impossible. And the not so fun way, here's the fishing line in the first video, and here it is for the second one.